and it maintains the lease information, which includes the options that were set, the IP address delegated or assigned, as well as the lease information, lease duration information associated with the assignment. Now we should also note that by default, etcdhcpd.conf contains useless information other than a pointer to a sample configuration file. So this needs to be configured based on the sample file. Let's take a look at that. We'll navigate to etc and less dhcpd.conf, and notice it simply points us to user shared doc dhcp, the version number of course, dhcpd conf. So let's copy the path and use less to tab it out, dhcp-305 dhcpd.conf.sample. Here's a sample configuration file that's useful for our intents and purposes. So what we'll do is copy this to the local directory as dhcpd.conf. We'll then, after we've overwritten it of course, we'll then manage it or open it using the nano program. And once in, you'll see some sensible settings. Global settings are placed outside of subnet blocks, and for obvious reasons, or it should be obvious, anything that pertains to a subnet will be contained within subnet blocks. So subnet 192.168.0.0 could pertain, and once we renumber it to 75.0, will pertain to the internal 192.168.75 network, whereas settings outside of the subnet block pertains to all subnets. Indeed, one DHCP server can service an unlimited number of subnets, providing the server has connectivity or is the target of a relay. So if multiple subnets relay either via a router, as we've seen in this case, or DHCP relay is running on Windows or Linux or any other OS into your DHCP server, then your DHCP server will receive the request for the various subnets and will need subnet blocks to be able to assign an address range to the clients making requests. But again, there are many global settings, and again, no need to memorize them because there is documentation, oodles of documentation included with the system. And you can simply let's log off this remote system here to take a brief look. If we rpm query list DHCP, and that's query all lists, that's the wrong option, so we'll kill it. And looking at the man page, we see dhcpd.conf. So if you man dhcpd.conf, we'll see the various directives that are supported in the file. Again, global parameters are outside of subnet blocks. Subnet blocks are subnet-specific parameters, such as default gateways. Those are certainly subnet-specific for multi-subnet networks. And there are many other settings supported by DHCP, such as the ability to group and set reservations and so on and so forth. We'll be looking at setting up a subnet as well as setting reservations. So let's return to the shell where the dhcpd.conf file is and begin definition. So we've got some directives for DNS and client updates, and these pertain primarily to Windows systems looking to update themselves in DNS, as well as Linux systems that want to update themselves with DDNS servers, or servers that support dynamic DNS information, changing DNS information. So for example, some of your clients might be DHCP, and if their addresses change from time to time, then that information needs to be republished to the central DNS server, whether Windows, Linux, FreeBSD, Solaris, what have you. The protocol is a standard protocol for updating DNS information. So with that said, let's make a few changes. We'll ignore the DDNS update style interim and ignore client updates. Just consult the man dhcpd.conf for further information and change the subnet from 00 to 75.0. The net mask suffices. It matches what we're currently setting. The default gateway that is set with the option routers directive and is actually 75.1, not 0.1. We're not using an IS, so for any item you're not using, comment it out using a hash mark. The domain name is linuxcbt.internal. This is to be set on all internal systems. DNS servers include 75.100 and any other box that may service DNS requests on our network or off the network, such as an ISP system. Now, one of those hosts is a 68 address and can be indicated using a comma after the first entry. So, internal host, comma, external host located at 68.94.156.1 will populate the client with this DNS address. And if you have additional DNS servers, just indicate them using a comma delimiter. It's that simple. Option time set, this is for Eastern Standard Time. NTP servers, we do have at least one. So we'll set 75.100. We're currently running no WINS servers, so we'll leave this commented. And so far so good. The definition of this particular subnet is in order. We do need to set a range of addresses. Otherwise, the DHCP server will not know what to serve to the client. So we must set a range. However, the keyword dynamic boot P is not required. So we'll just comment this out and include a new range directive indicating the lower address, which will be assigned last, and the higher address. Now let's say we want the range to be 100 through 200, or let's say 150 through 200. So 75.150 on the low end through 192.168.75.200 on the high end. This will ensure that the 200 address is assigned first, and it will decrement down to 150. So 200, then 199, 198, 197, and so on. We've got a default lease time measured in seconds, 21,600, divided by 60, that'll tell you how many minutes, and a maximum lease time. In other words, the client cannot hold the address and the address information beyond 43,200 seconds. This is the reservation section, which we'll comment for now. We'll turn on momentarily. This is a way you can ensure that a client is always served a specific address. And with that, the configuration is over. It's a very simple configuration. If you do have additional device types, by all means, add them. But this is all that's required to get the server up and running. So with that said, let's set up a server so that it starts automatically when the system boots by saving the changes to the config file. And we know that in etc init.d, the service exists as DHCPD, so with that said, we'll check config DHCPD on, or optionally using the levels option, we can determine which levels the service should run in. So 3, set service up to start when system boots. 4, disable service on 192.168.75.100 box. 5, start service on local hosts. And it will be up and running version 3.x. Now, the version running on the remote system is also major version 3, so the configuration is close to the version that we're running on the local system. So check config ensures that DHCPD is on. If we now check config list, we see that it's set up for 2 through 5. And if we connect to the remote system, the 100 box, let's find a free shell here to be able to connect to it. We'll Control-Shift-T to open a new one. Then SSH to 168.75.100. And since it's a SUSE box, we'll RC DHCPD